two circles with center O and O dash of radius 5, not 5, sorry, 3 and 4 respectively intersect at point P and Q such that OP and O dash P are tangents to the two circles. Find the length of the common chord. So first thing first, we have the centers O and O dash. Then the radius of this is 3 and 4. So we have this to be 3 and this to be 4. So they intersect, the circles intersect at these 2 points. That is where the circumference meet is what they're talking about. So they are meeting at P and Q. So that's P and this is Q. Now, if I happen to join OP and O dash P, so they happen to be tangent. Similarly, at this end also, we have the tangents. So we have something like this. Okay, so let me kind of make it a bit better to look at, not confusing. So we have the first tangent, we have the second tangent. So this would be O and this would be O dash. This is 4 centimeter, this is 3 centimeter. So I have to find the length of the common chord. This would be your common chord. Right? What is a chord? Chord is a line which is from one end of the, like say you have a circle. Chord is a line from one end of circumference to the other end of the circumference. Okay? And so we have this to be 3 and this to be 4, and we'll just join this. Let's see what happens now. Okay, how will we work this out? First thing first, we know that the tangents and the radius do make an angle of 90 degrees, so that's 90 degree. This length is equal to this length, this length is equal to this length, this length is equal to this length. They are radius basically. If I join this, because this is a right angle triangle, this length will be 5 centimeter. You know, O to O dash would be 5 centimeter. Now the question is, how much is PQ? PQ. Right? How much is PQ? How do you figure it out? So, well, we know that O dash is 5. If I take this as x and this as 5 minus x, maybe things will work out in some ways. And we have the chord. If this is y, this also is y. But why? You know, why is that I'm able to write this, both this lengths are equal? Well, the reason is quite simple. See, what we're looking at is a kite. So if I happen to draw it on the sides, a kite is a structure, a quadrilateral to be precise, wherein we have two adjacent sides, two pair of adjacent sides to be equal. So if we draw the diagonal from the non-adjacent, from the sides which are not equal, which are equal basically, from the vertex containing the equal sides, right? That will bisect the diagonal which is connected from the vertex containing non-equal sides. Okay, so basically this length is equal to this length. This is the midpoint for say AB. So you can tell O is the midpoint for AB. Okay, and also the diagonals are perpendicular to each other. Okay, so there are quite a few reasons with which we can explain this. So this 2 is y and so on and so forth. So from this diagram we can get two equations and there are two unknowns, we need to solve them. So this is the entire funda. It looks complicated. Hopefully as and when I write, you guys will catch up with the required knowledge. So we'll call this as O and this is O dash. Yeah, that's correct. So that would be one of your radius, another radius. They are perpendicular to each other because they are tangent and radius combination. So if I join this, I'll be able to find this length using Pythagoras theorem. So let's do that first. This is P and this is Q. So we have a diagram and then we have okay, nothing else I guess, or we'll just tell join O dash and PQ. we'll do that later. Now they're working. So what do we have? We have OP is perpendicular to, or we can tell angle OPO dash is equal to OQO dash. Both of them are equal to 90 degree. The reason being, what? Radius is perpendicular to tangent at the point of contact. Okay. Then we have in triangle OPO dash. What do we have? We have OO dash the whole square is equal to OP square plus PO dash the whole square using Pythagorean theorem. And now on substituting, we have OO dash the whole square is equal to 4 square plus, oh sorry, this is 3 and 4 not. And this would be 3 square, other way around, but anyways, doesn't matter. 16 plus 9, that is 25. And so O dash is square root of 25, which is 5 centimeter. Okay, till here it's quite clear, is it not? Now, if I just consider the structure O, P, O dash, Q dash, right? So, N, O, P, O dash, Q dash as the, okay, let me do it step by step. OP is equal to OQ, the radius being equal to 3 centimeter. O Q dash, O dash Q and O dash P, they two are equal to each other because they are radius of another circle. Now, thus, since the adjacent sides are equal, thus the, oh wait, I didn't explain why is this, why I can use Pythagoras theorem over here. Oh no, I did, my bad. Thus, where was I? Thus the quadrilateral is a rhombus. Okay, and now we can tell from this O dash bisects PQ and are perpendicular to each other. Again, all this is the property of a rhombus. Okay, so I'll give stars to this. And now this being perpendicular, we can call the point of intersection as, say, M. Let the point of intersection be M. Let M be point of intersection of O dash and PQ. Okay, so what do we have? Then we can call PM is equal to MQ is equal to Y or something like that. And we have a bit of writing to do. So let PM be equal to Y. Then we tell PM is equal to MQ. Both are equal to Y. Right? We have the reasoning. So we can tell from 1. Okay, what else then? This is Y and that's Y. Next we have OM to be, if it's equal to X, then M O dash is equal to 5 minus X. Then if we have, let OM be equal to X. So we have OM dash, which is equal to OO dash minus OM. is equal to 5 minus x. Then what do we have? In triangle MOP, right? So we have OP square is equal to OM square plus MP square. Okay, so all the reasoning is written, no need to worry, we can just go with the flow. So we have 3 square is equal to OM is, I think I called it as y square, right? OM is x, sorry, and MP is y. So this would be our equation A. Then next equation is in triangle, the other triangle, in triangle MOP is MPO dash. MPO dash. So what do we have? We have O dash P the whole square is equal to PM square plus MO dash the whole square, and here we have 4 square is equal to y square plus this is 5 minus x the whole square. Okay, again all of the reasoning is written, so you just have to go with the flow. And here we are going to make use of the formula a minus b the whole square, which is so on and so forth. So this is 16 is equal to y square plus 25 plus x square minus 10x. And now what should we do? We should handle a and b. So what should we do with a and b? We can subtract b minus a and we'll get what? 16 minus 9, that is 7, I guess. Then we have x square getting cancelled, y square getting cancelled, and we are left out with 25 minus 10x. So since I don't have space, I'm trying to squish everything in. So 10x to the left hand side and 7 to the other side. We have this to be how much, guys? 18. So x is equal to 1.8 centimeter. And y we can find using substituting in. So we have substituting x in a. What is that we are looking at? So y square is equal to 3 square minus 1.8 square. So this would be 9 minus 1.8 is how much, guys? 1.8 is 400, 324, I guess. I think 1.8 into 1.8. Yeah, 324 and the decimal, 2 point decimals, and we have y is equal to square root of 5.76. This is nothing but 576 is 25 24 2.4 centimeter. All this you kind of need to know. 24 into 24, right? The same number, and therefore the chord length, chord 2 times of y is equal to 4.8 centimeter. Okay, right? I hope you guys learned quite a bit from this question, especially this part. Everything else is Pythagoras theorem, but the property of rhombus has to be known. So again, this is part of your old syllabus, and that also you guys can download, right? All the properties of, not too many, I think only rhombus, then we have kite. I think only these two properties you guys kind of mess up. Actually, Pythagoras theorem, then we have property of trapezium, formula of trapezium, and all of that. There are quite a few. You guys need to know them. That's how it is. If you want to score 80 plus, all this is must.